Now, I'm going to assume everyone had a good nap in the last session, lunch and then nap. I'm assuming especially anybody that went to Richard's talk, because Richard is incredibly entertaining, which I'm sure you'll all see tonight, but his voice is also so soothing, which is an interesting selection for the after lunch slot. So this afternoon, I'm going to be talking about testing, specifically testing front end of websites and applications using GitHub Actions. First of all, I'm not going to delve too much into why you need to be testing or why we need to test the front end of our applications. I'm assuming if you are in this talk, you understand that testing is probably pretty important. If not, you'd be in the other testing talk that Lars is giving at the moment. So I'm going to assume that everyone here understands the importance of testing. If you don't know why you should be testing the front end or aren't quite convinced yet, there is another talk that I gave a few years ago that I recommend checking out, where I delve a lot more into testing front ends. Today we're going to focus more on the automating from a CI/CD pipeline point of view. But the important thing we need to remember when it comes to testing the front end is, as the name suggests, we need a front end to test, which generally means we need a live website. Unlike when running other tests, like for example, unit tests, you can give it dummy data and make sure that the output is the same. For front-end tests, we need a functioning front end to be able to test against. For example, from this code snippet, can you tell me if the interface is accessible to someone with a vision impairment? Can you work out how fast the page is going to load in a browser, or if any of the resources might block the page rendering? If you look at this CSS code snippet, can you determine if any of the code changes will bleed out to another part of the application? Is the styles going to only change what you intended to do, or is it going to accidentally affect something elsewhere? As the name suggests, front-end testing needs a functioning front end to test against. While we can perform some linting and validation without having a functioning front end, there's only so much we can do without seeing the final product. Ideally, this should be in as close to production as possible. In particular, if you're doing performance testing, you want to have an environment that is close to production as possible to get accurate results, which we know everyone always loves having another very expensive environment required. So why GitHub Actions? This is a really great question that I want to address in two parts. First off, while manual tests are better than no tests, manual tests aren't great because it's hard to ensure that they're being run. Who here trusts that every single member of your team would absolutely manually run tests if you were required? It's fine, I won't tell the rest of your team that you don't trust them. How many of you enjoy doing a repetitive task that could be easily automated? None of you enjoy this. And this is one of the things that we love using AI for. And so it's one of the great things about tools like GitHub Actions is we can automate so we know that our tests will run every time without us needing to do it manually. When tests are automated as part of a process, we know that they're actually going to happen. We can add a check-in to make sure that the tests are actually being run, because apparently you don't just have to write tests, apparently you have to use them as well, otherwise there's no point. When a pipeline is set up properly, we can also ensure that any code that doesn't pass tests won't get merged in, and we can protect the quality of our application. But why did I choose GitHub Actions in particular for running the tests? Why did I particularly choose it for my CI/CD tool? Well, a lot of it came down to the fact that the documentation and assistance available to me was really good, and it meant it wasn't hard to get started. Part of it came down to the fact that I knew a bunch of people that did a bunch of stuff with GitHub Actions, and so I could bug them if I had any questions or problems. It was also compatible with a lot of existing things that I knew I was going to want to do, and has really great extensibility, so works for smaller projects or bigger enterprise projects. So while the code that I'm going to be talking about today is specific to GitHub Actions, the product itself, a lot of the concepts are applicable to different CI/CD tools if you use something else at work. For those who aren't familiar with or haven't heard of GitHub Actions, it is a very powerful tool that I could do an entire talk just talking about what its capabilities are. If you want to look into it a bit more, I recommend checking out the GitHub docs, or I think there might be a few people from GitHub today or tomorrow. You can flag them down and ask them questions. Now, GitHub Actions runs what we call workflows, and these are written inside of workflow files, which are inside of a particular folder inside of your code repo. As with a lot of I swear I tried to cover it. As with a lot of DevOps tools, these files are written in YAML because we love writing YAML, right? Definitely don't spend far too much time wondering why it's not working because the YAML thinks a space is a tab is a space. I don't know, it throws tantrums. Each workflow or GitHub action runs one or more jobs. By default, these jobs will all run at the same time, but you can get them to run one after another. And each job is made up of a number of steps, which will run one after another. Now, to define our workflow, we will give it a name. So we have the name of the workflow. We can then choose how we want our workflow to be triggered. In this case, I want it to be triggered every time a pull request to my production branch gets opened, reopened, or the code inside the PR gets updated. Now, when we're looking at triggers, there are a lot of different triggers available. There are many, many options of events that happen inside of a code repo that can trigger a workflow. These are just some of the more common ones. Most of these actions then have further settings that you can filter down to more specific events. For example, a pull request trigger allows us to define the different types of events that will trigger the workflow. For example, a pull request is assigned, unassigned, if it's ready for review, that kind of thing. Or whether all pull request events would trigger it. We can also filter down to specific branches. For example, we might just want to focus on pull requests to a particular branch. And we can also filter down based on file paths that have been changed. For example, if I'm looking at validating CSS files, I probably only need to run that GitHub action anytime a CSS file has changed. So we can filter it down that way. So in this case, we're going to keep it nice and simple. I want to trigger on pull requests. I want to do this when a pull request has been opened, reopened, or synchronized. So synchronized means somebody else has pushed code to the branch for that pull request. And That means it will only run if the code in a PR is changed. And I want to do that for any PRs to my production branch. I don't care about the other branches. I know that the code in all the other branches doesn't work and doesn't need to be tested. I only care about testing the production branch. Next, I want to go through and define the jobs of my GitHub Actions workflow. Each job gets a different name, in this case, build, because this is where I'm going to build my website. This name must be unique though, because we can use it to refer back to later. I then want to set the platform that the workflow is going to run on. Most of the time, we're probably going to be running on Linux. In this case, I'm selecting a particular Linux version. There are a bunch of different Linux versions available, and also Windows. It's a little bit weird the way they've worked out pricing, because Windows GitHub Actions are billed at twice as many minutes as Linux. Rather than make it a different price per minute, they just said that each minute is worth 2 for some reason. So it's a fun thing to work out if you need to run any workflows on a Windows build. Next, I have steps. So these steps will define what the build job is doing. And we will go through and define some steps. So I've got a few steps in my workflow, which we're going to talk about a little bit. Each step will have a name. This is a user-friendly name. This is just so we can identify what is happening at the particular point in time. It is not required, so sometimes we may not use it, and so this would be something like setup node or run custom script. We can also give a unique ID to a step. This is useful to be able to refer back to it from other steps. Next, we say what the step actually does. There are 2 ways that we can do this. One is to use an existing GitHub Actions package. We use this using the users property. Other ways, we can run a script within the GitHub Actions workflow runner. And so we do that the same as we would run it in a terminal. We can also set up conditions for each step. So some steps we might not need to run all the time. Some steps we may not only need to run if a particular condition is being met. So in this case, if there's an error in one of the previous steps, if something has gone wrong, we can get it to tell us that something's gone wrong. But we only need to run that step if something has gone wrong. So we can check for conditions. We can pass in environment variables. We can use these to reference any GitHub Actions secrets or any additional values that we want to give. And lastly, we can use the with property to pass in any additional info that the Actions package might need. So this works a bit similarly to environment variables, but generally refers to something that's not really secret. For example, when we're setting up Node, we need to tell it which version of Node we need. This doesn't need to be saved as a secret, so we can just pass it in using the users property. For now, on my workflow, we're going to set up 3 steps. We're going to have checkout repo code. Most of the time, this is going to be the first step of each of your GitHub workflows. This is going to get access to the code of the repo, otherwise you can't do anything with it. So most of the time that's going to be your first step. The second step, we're going to set up Node because I'm building a website, which means it's running on JavaScript somehow, so I'm going to need to have Node set up. And lastly, I'm going to install Node modules. Now to do these, I'm going to use 2 existing GitHub Actions packages. First off, It's going to be the checkout code package, which will check out the repo code. Secondly is going to be the setup node package, so that I can set up node. And lastly, I don't need a package for this. I can just run npm install the same way I would on my computer. As we looked at previously, the setup node package allows us to define the version we're going to use, so I'm going to define that so that I know that it's not going to have any breaking changes. Once I've gone through and done this, I then have a GitHub Actions that will be available inside of the repo, so you can find this under the Actions tab in the GitHub repo, and any runs will appear here. So if I open a pull request to my production branch, this will then trigger my GitHub Actions workflow to go through and run. And we've only got a couple of steps. All it's doing is installing, setting it up, getting the code, setting up node, installing node modules. So thankfully nothing went wrong with that. And it says all checks have passed, and so technically I should be able to merge my pull request there. But I need to actually build the website there, and we need to deploy it somewhere. This is, so to build and deploy the website, I'm going to deploy it to a service called Netlify. I use this because this is where I host a lot of my websites, because most of the time it's free and it's really easy to use. So I'm going to build and then deploy the website to Netlify. I also use this because it does really great deploy previews, so I can get a preview of what it's going to look like before it deploys to production, which is what I'm wanting to do here, so I can have different versions of it running. Now, this particular step will be different if you're hosting it on different platforms. For example, if you've got it on Azure or AWS or somewhere else. In my case, so most of the time there are existing packages that you can use. In my case, there's not a great deployed a Netlify GitHub Actions package. So I did what all good developers do, and I built my own script to do it rather than just using something else. Thankfully, Netlify has a CLI tool which made this fairly easy. So I created a bash script, added it to my project, and I can go through and use that to build and deploy the site to Netlify. I'm just going to quickly go through the command, but as I said, this is relevant to just building and deploying on Netlify rather than anywhere else. So here, this is the command using the CLI that I would run. Next, I want to save the output of the command to a variable so I can access the information later. I then want to pass that output because that spits out a whole bunch of JSON, and I want to get just the URL part of that. So I'm going to pass the JSON, and then I'm going to save that as an output of this particular step. To run this script, I'm going to add another step, which is deploy to Netlify. Now this one's a little bit different because I'm going to give this step an ID because I want to refer back to the URL that we're going to get from it. So in this case, I'm going to give it the ID of build site. I'm going to pass in a few environment variables. In this case, there's going to be a token and site ID so that the Netlify CLI knows which website it's building and where it's deploying it to. And then I'm going to go through and run my bash script that I wrote. The step that I always forget to do, and then I wonder why it's not working, is I need to then add the secret values for my token and my site ID that I'm going to refer to. So inside of settings, secrets and variables actions, I need to make sure I'm passing in the environment variables that I want to use as GitHub secrets. Once that's done, I can submit a PR to production, and all my tests have passed, which means this is deployed to Netlify. But I don't know where it is. I don't have a URL that I can go through and run tests on. So we did get that from the script. We got the site URL, and so I need to access that in a later step and do something with it. So my next step, I'm going to use the GitHub Actions script. This allows me to do a whole bunch of stuff in GitHub. In this case, add a comment to my pull request, which is actually an issue because pull requests and issues are the same thing for some reason. So I'm going to add a comment to my pull request, which is an issue. I'm going to pass in information about my pull request, which I can get from the GitHub action, and I'm going to then pass in a whole heap of information, including the URL that I got in the previous step. So I'm going to refer to my build site, the ID for build site, and inside of the comment that I'm adding, I want to refer to steps build site output netlify URL, which will allow me to access the URL. Because I'm adding comments to my pull requests, I need to give GitHub Actions permission to do stuff on the repo it's on. So I need to make sure the workflow has permission to read and write on my repo, otherwise that won't work. Then, once it does, I can run my action again, and it will give me a URL of a live website. So I'm able to go through and see this and make sure that that's all working because it adds a comment to my PR. And here is my live website that I can go through and test. Now, I talked briefly about the fact that this build step is specific just to Netlify. Different platforms have packages and we would do things a little bit differently. So in this case, I'm running a shell script. For example, if I wanted to deploy to Azure, I would use the Azure deploy package, and I could do it that way. The Azure package then requires me to pass in a whole bunch of information. For example, this is the static website that I'm using, this is the token, and a whole bunch of information about how it should go through and build. So we can go through and run this build step on different deployment platforms depending on what it is that you're wanting to use. So in this case, I've gone through and run the build, and not only is it building and deploying to Netlify, I'm now also deploying and building to Azure Static Web Apps as well. But this is all very cool. This talks about testing. We have a live website. We have a live website with a URL we can access and refer to. Next, we have to go through and run the tests. So we've got our build job. I'm going to create another job in the workflow, which is to test. I'm going to do this just to keep things a little bit separate. Could actually put it all in the same job if you wanted. Probably would have made things easier for me, but it's working now, so that's the important thing. So the same as previously, I want to go through and define the platform that I want to run it on. Probably want to run it on the same thing it's built on because it just makes it a little bit easier. Then I want to go through and I want to be passing my live URL from the build job to the test job. Now to do this, I need to define an output on the build job. In this case is deploy URL. And then I need to set a condition, I need to set a requirement that the test job needs the build job to complete first. If something's gone wrong with building the website, there is no point trying to run the test because it's not going to work. This also means that it won't start on the test job until build is completed. So we talked about how jobs will run at the same time by default. Because we've set build as a condition of test, it won't do that until the build has completed. Next, we want to go through and define steps for the test job. Now, because these jobs are completely separate from one another, the first thing we're going to have to do is check out the code again so that we've got our tests to run. The first test I'm going to go through and run is Lighthouse, because this gives us a whole bunch of information about websites. So I'm going to go through and run this one, and I know I'll get a nice little report at the end. This is also super easy to do in GitHub Actions because there's a package. So I'm going to use the Lighthouse CI Actions package, and I'll get a report back from this afterwards. We can pass in some information to the package with what we want it to do for this particular step. In this case, I want it to upload the report that it will generate because I want to actually see the results of it. And I want to pass in the URL of our website that we've deployed previously. So, in theory, I should just be able to pass in, because we said this is the deploy URL. We pass the deploy URL so that we can access it in the test job. So we should be able to go through and do this. But there's a fun feature in GitHub Actions, which I fully understand is done for the reasons of security and making sure we don't accidentally publish sensitive information to the internet. But what happens is, if we go through and do this, it's not going to work. It's going to fail. And it's going to tell me I haven't given it the deploy URL, even though I have. And if I look, hidden away in the comments is a tiny, tiny little warning. It's not even an error. It's a warning. Warning, skip output, deploy URL, since it may contain a secret. So, the deploy URL that we got back for our live website contains a whole bunch of randomly generated characters and contains the site ID in Netlify. The site ID is a GitHub secret because we have passed that in. So it goes, part of this string matches this secret string. I don't trust you. So I'm going to just assume that this is an accident and you don't want this to happen, and I'm not going to pass that information through. I'm not really going to tell you, I'm just going to secretly whisper, just really quietly, that I'm not going to do that. I spent so many hours trying to work out why this thing wasn't working before I discovered that this is a thing. Thankfully, I wasn't the only one. So somebody else has already figured out a solution for it. So what we can do is, when we get the deploy URL, when Netlify finishes building the website, we can go through and get the deploy URL, but then we can base 64 encode it so that it doesn't seem to contain the site ID. Now, I wasn't sure, so I just base 64 encoded it twice just in case. Definitely not because that's what Stack Overflow did, and I didn't actually look at it closely when I copied and pasted it. So we're going to encode the URL so that it doesn't contain a secret number. And then when we pass that through to the test job, when we're in the test job, the first thing we're going to have to do is we're going to have to go through and decode the URL. And so we can go through and run a script to take that encoded value and decode it again so that it definitely doesn't contain a secret, and it's totally fine for us to have that information again. And this is definitely not the bit where I couldn't get it to work and I couldn't work out what was going on. And thankfully at that point, AI was the thing, and I asked it and it told me that's because I base 64 encoded it twice, but only decoded it once. So yeah, that was a fun thing to work out. So we get to go through and do this, but what that then means is we get access to our probably secret, best not to put it on the internet value that GitHub is making sure that we don't access, which I understand it's a security thing. Security is important. It's just a pain at 2 o'clock in the morning when you're trying to get a demo working and can't work out why it's not. So now that we've got the decoded URL, we can pass that one through to the Lighthouse tests, and it will go through and run the test. Now, we talked briefly about how we were uploading the report as well. Once it goes through and runs the action, we then have a section called artifacts, and it will give me the report that it's uploaded available to download. So this is because we said upload artifacts is true, and I can then access my report, which tells me that I probably need to do a bit of work on the performance side. But we're then able to go through and run the test, get the results of the test, all automatically happening. Whether I want the test to run or not, doesn't matter, it's happening. So people know that the code that I've just written is likely to cause some performance issues. So I haven't gone to a conference in a really long time, and I've done far too much talking in the last 2 days, and I've lost my voice. So got a bit of a cough, definitely need more tea later. Next, I want to go through and run some Playwright tests, because I actually really enjoy using Playwright for testing. I found it was a really great tool and really easy to use, and it's relatively easy to integrate with GitHub Actions as well. So I'm going to use Playwright to run some UI tests. First thing we need to do is install the packages for Playwright. Playwright doesn't have a GitHub Actions package. I can just go through and install it in the command line. Then I want to go through and run my Playwright tests. And lastly, I want to upload the report that Playwright's going to give me. So I need to do this manually using the upload artifacts action. Now, if a step fails, it won't keep doing other steps. It assumes that, well, because this one didn't work, you don't want to do the other things. However, we can set a condition that this should always run. For example, if my Playwright tests fail, I still want to see the report. I want to know what went wrong. So this should always run. And I want it to upload the Playwright report folder. I then want to hold on for it for 30 days, because then when I have to look back in it in a couple of weeks, I can still find it again. But I'm not going to clutter up my repo with a whole heap of old reports. So I'm going to go through and run my Playwright tests. And then inside of artifacts, I will have access to my Playwright report, which tells me all about the Playwright tests, whether or not they've passed. Then I can go through and, you know what, I'm actually probably pretty happy with the tests that are running at the moment. I'd be fairly confident with clicking merge pull request at that point. But nothing's going to happen. So we're currently building the website, checking that it's all good, but I need to deploy it. So I'm going to create a new GitHub Actions workflow. I'm going to call it build and publish, because this is when we're going to build the website and publish it, make it live. And in this case, I want this to happen anytime code gets merged into production. So whether that is a pull request has been merged, or whether someone has done what we definitely don't all do and just pushed straight to production. Either way, I want it to build and publish the website. So we're going to go through and set up a build job. Again, same, use Linux, run steps. The steps are pretty much the same. We want to check out the code. I want to set up Node. I want to install the Node modules. And then I want to deploy to Netlify. going to use the same script that I used previously for a deploy preview, but this time I'm going to pass in a production flag, and I'm going to make a couple of quick changes to my script so that if I pass in a production flag, I want it to pass the production flag to the command, and I want it to, rather than do a deploy preview, which is a live version in a unique URL, I want it to just push straight to production. Now, if I look inside of actions, I have two workflows. I have build and test and build and publish, and these will run when the particular triggers are met. So we can build and preview our website anywhere. We can test our live website, and we can then build and publish the fully tested, totally production ready code. Now, I talked a little bit about the really useful parts of GitHub Actions. And it's not just useful for testing, it's useful for a whole bunch of other things. There are tens of thousands of packages out there. So there are a whole bunch of different things that you can do, as well as being able to go through and run our own scripts, which means we can set up other automations to run as part of our workflow. Who here adds comments to themselves in code? Who here remembers to go back and fix the thing that the comment said that they need to fix? Lemon, you're lying. This is a note for future Amy that I will totally go back and fix later on. Definitely won't have forgotten about. So I'm going to go through and take advantage of, before I deploy my site to Netlify, I'm going to use a package which is to issue action, which takes all of my to-do comments and creates GitHub issues from them. So I have issues in my repo, and I can't forget about that. Now, as with some of the other packages, I can pass in information to do things. For example, I want to auto-assign the issue to the person that opened the pull request, which most of the time means whoever wrote the code gets assigned the issue because it's your problem. It's your fault. It's your thing you said you were going to fix. I also want to go through and auto-close the issues. So if the comment disappears, I'm going to assume that that means you did fix it and didn't just delete the comment. If the comment disappears from a later pull request, from a future code version, I'm going to assume that that means the problem is fixed, and we can go through and close the issue. So that means if I had a comment in my code that I need to fix this thing, it will create an issue in GitHub so that I don't forget about it, and everyone can see that, yes, I did say I was going to fix that thing, and I haven't. So we can then go through and more easily track the comments that we're creating in our repo. And then, yeah, we talked about auto-assign and closes. So this is another example of things that we can go through and add in GitHub workflows. So we can create tasks and issues for any comments and bugs. We can lint and validate our code. I'm assuming there's probably a few existing GitHub Actions workflows that will go through and run linting. We can check for broken links. There is an option to wait for a manual approval at some point. So you may get to a point where something's gone wrong, but someone can go in and go, yeah, that's wrong, but it's right, it's fine. So we can go through and do that. We can generate assets. For example, you may want to automatically generate a social media preview image for each page that you build on the website. I have a GitHub Actions on my blog, which every time I embed a tweet in a blog post, it will go and create a static image of that tweet and replace my live embedded tweet with a linked static picture of the tweet, which is super useful because it's much better for performance. I'm no longer loading anywhere near as much JavaScript on my website, which I always love it if I can get rid of some JavaScript. And more importantly, in the event that, I don't know, someone turned Twitter into a dumpster fire, like that would never happen. If something like that happened, I still have access to the embedded tweets, which included a whole bunch of context and information about what I was talking about in my blog post. So we can go through and generate things like this. We can do a whole bunch of admin on our repo. For example, a lot of open source projects have GitHub Actions that will go through and automatically add tags and assign people to things so that they don't have to do it. The repos that have thousands and thousands of issues and pull requests, we can go through and automate that easily. So, I think we're doing okay for time. This is the code repo of the tests that we've run. If you don't believe me, because I haven't actually done any live coding, because every time I try and do live coding, it doesn't work, to the point where even my husband asks me every time I have a talk, do I have any live coding and do I have the backup for when it doesn't work? So if you don't believe me, here is the code repo where we can go through. You can see the actions where they run. You can see the code for the workflows. So you can see how that all works. I also have a blog post which goes through a lot of the same information if you want to refer back to this later, or if you want to pass it on to anybody else in your team, how you can get started with doing front-end testing with GitHub Actions. And lastly, if I haven't convinced you and you would like to know more about testing the front end, I have a talk that I gave a few years ago on front-end testing, which I recommend checking out. We delve a lot more into what the tests that we automated actually are and how to write them. Thank you very much for your time this afternoon. Does anybody have any questions? Yes?
It's a very boring one, because I was head of engineering. Supply chain injection by using actions from random people.
Supply chain injection by using actions to random people.
How do you know you haven't got a malicious GitHub Actions going to do things?
Like the existing packages that we're referring to, how do we know that it's totally, you don't. No. So GitHub Actions packages are all public. I do believe if you publish an action, you have to also make sure the repo for it is public. So you can look at the code, but those are all public that anybody can do. So use best judgment if you are referring to an existing package, because the same as installing something from npm, there's no guarantee. There are some, like GitHub's got a whole bunch that it's created. I feel fairly confident in using one of them, or one that Microsoft or Amazon has created. But there's a whole bunch of third-party ones that, do not come and complain to me if you find this really cool package and we used it and then someone hacked everything. So you're still including other people's code and giving it access to what it is that you're doing. So do that wisely.
I think our conclusion was, if it's a simple enough thing that you could build it and write it and you wrote it, because like your shell script that you have as well.
And that's part of the reason why I did that, was just to show how easy it is to write. Hang on. I don't like to say that because I don't find it easy to write shell scripts. But if you were somebody who was able to write a shell script, which I'm sure someone in your team is comfortable writing shell scripts, you would be able to write a shell script and run it. Or just run things in the command line the same way you would on your computer. So that, yeah, there's definitely other options that you can use. Yep.
It's more of an extension of this discussion. Since we're talking about security, you'll probably run on your own premises. And we did so, San Diego Supercomputer Center. And apparently, you can actually create your own Docker containers, which will be then GitHub runners. And then you can basically install all the required infrastructure already in those containers. And so get rid of those, like setup and all stuff, and providing secrets without simply mounting images and stuff.
Yep. Yeah, so Docker absolutely, yeah, as you've said, integrates really well with GitHub Actions. One of the main reasons I don't use it is because I don't like using Docker. Every time I try and use Docker for something, it doesn't work for me. So it's just sort of go through and setting it up. But yeah, if you did have that case, yeah, using Docker to self-contain it would absolutely be a good solution. And probably for a lot of repos, that would be what makes sense. If your development environment and your production environment, you're just running everything in Docker, you just run it in Docker the same way. Any more questions? Nope. Awesome. Which that means you get to be like the front of the line for the food out there, although they may not have they're not putting food out to like the last minute. They're waiting until everybody's meant to be there. So I am going to be around for the rest of the conference. I might disappear a little bit this afternoon because I'm just going to drop my bag off at the hotel, but you should be able to find me later on this evening. Otherwise, I will be here tomorrow. If you had any questions or wanted to talk any more about front-end testing or GitHub Actions, yeah, come and find me. Thanks for coming along.